Assalamualaikum and good morning. Today our group will present about fluid mechanic project. We are from group 8. This is our group member. First, Muhammad Adik bin Muhammad Zuharul. Second, Muhammad Arif Ajmal bin Azmin. Third, Muhammad Haziq Aiman bin Zaidi. Fourth, Muhammad Luqman Hakim bin Muhammad Junid. And the last one, Muhammad Naim Firdaus bin Mazlan.
Hello, Assalamualaikum. My name is Muhammad Adik bin Muhammad Zaharul. My metric number is AF200089.
Assalamualaikum. My name is Muhammad Arif Ajmal bin Azmi. My matrix number is AF200053.
Wabarakatuh dan salam sejahtera. Nama saya Muhammad Haziq Aiman bin Zaidi. My metric number is AF200109. Saya ialah pelajar Fakulti Kejuruteraan Awam dan Alam Bina.
Wabarakatuh. Nama saya Muhammad Luqman Hakim bin Muhammad Junid. Laboratori AF20021.
My name is Muhammad Naim Firdaus bin Mazlan with number matric DF180207.
Introduction. Piping is a system of pipes used in the industry to convey fluids from one location to another. The engineering discipline of piping design studies the efficient transport of fluids. In the industrial, the process piping can be manufactured from wood, fiberglass, glass, steel, aluminium, plastic, copper, and concrete. This component known as fittings, valves, and other devices typically sense and control the pressure, flow rate, and temperature of the transmitted fluid. Second, analysis of the pipe network is an analysis of the fluid flow through a hydraulic network containing several or many branches that are connected. The objective is to determine the flow rates in the individual sections of the network and the pressure drops. Once the pipe's friction factor are obtained or estimate from the law of pipe friction, the measurement of the flow rates and the head losses on the network can be considered. The head losses at each node are usually ignored, and a solution for the steady state flows on the network is found, taking into account the pipe dimension, lengths and diameters, and property of pipe friction and known flow rates or head losses. Last but not least, the Hardy-Cross method is an iterative method for determining the flow in pipe network system where the inputs and outputs are known, but the flow inside the network is unknown. The method was first published in November 1936 by a namesake Hardy-Cross, a structural engineering professor at the University of Illinois at Urbana-Champaign. The Hardy-Cross method is an adaptation of the moment distribution method, which was also developed by Hardy-Cross as a way to determine the moment in indeterminate structures. The introduction of the Hardy-Cross method for analyzing pipe flow networks revolutionized municipal water supply design. Before the method was introduced, solving complex pipe systems for distribution was extremely difficult due to the non-linear relationship between head loss and flow. The method was later made obsolete by computer solving algorithm employing the Newton-Raphson method or other solving method that prevent the need to solve non-linear system of equation by hand. The Hardy-Cross method provides a system for calculating the value of the correction to be made, each loop or junction being considered in turn and corrected, assuming that conditions in the remainder of the network remain unilateral.
Okay, for the calculation, the task given is we must use the method Hardy-Cross method with Hazen-Williams in order to determine the discharge Q and head losses HF. Okay, below is the detail. This is figure 2.1. this is figure 2.2. In the table of detail, we can see Q inlet, Q outlet, loop, method used, and type of pipe. Okay, for the figure 2.3, which is friction factor for pipe network, we can see line, friction factor, and length. And the last one is figure 2.4, which is table of resistance in each pipe. Okay, in this project, we can use formula K, which is resistance. K equal to 10.70 the power of L divided by C for the power of 1.85 times D the power of 4.87. Okay, as we can see, there is HF equal to K times Q power of N, where N is 1.85. Okay, for the try one, this is figure for the try one. For the loop one, we get after we use the formula, we get negative 47.09 divided by 4874.12, and we get 0.0097. For the loop 2, we get 46.68 divided by 5991.82, and we get 0.0078. For the loop 3, after we use the formula, we get negative 1.31 divided by 3631.53, and the answer is 0.00036. And the last one, which is loop 6, we get negative 32.6 divided by 10,634.53, and we get 0.031. Okay, for the second try, this is figure for second try. For the loop 1 in figure 2, in the try 2, we got negative 7.9 divided by 1508.96, and we got 0.0052. For the loop 2, we got 34.37 divided by 2808.05, and the answer is 0.0024. For the loop 3, we got 0.00069, and the last one, loop 6, we got negative 2.36 divided by 10,732.57, and we got 0.00022. Okay, for the last try, which is try 3, this is figure for try 3. For the loop 1 in try 3, we got negative 6.83 divided by 2506.82, and the answer is 0.027. For the loop 2, 29.41 divided by 4783.83, and the answer is 0.0061. For the loop 3, we got negative 0.24 divided by 3201.25, and the answer is 0.000075. And the last one, which is loop 6, we got 0.01 divided by 10,717.25, and the answer is near to 0. Okay, the last part, which is conclusion. As conclusion, the Hardy cross method, which Hazen-Williams can help to determine the discharge Q and head losses HF in the pipe analysis network. In this task given, the method to solve the task had been done as 5 trial. The last trial shows that the value of correction in the selected loop had achieved 5 decimal points. The results show that in trial 5, which in the loops 2 and loop 3 got the 5 decimal points value of correction, which are 0.00017 and 0.00065. From the results, it can show that the pipe network are in good condition from for running the system because the value of corrections are nearly to zero. The Hardy cross method, which Hazen William are useful to determine the pipe network analysis. The method can give early exposure for students in understanding the pipe network analysis as improve their skills and knowledge about flood mechanics. This exposure also can help students to understand the stable condition to use as they reach into work after they graduate. That's all from us. Thank you.